So Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem. So you're going to do the solution and do some coding work. And the second goal is to see how we should behave in the real interview. So let's get started. So remember, in the real interview, the first step is to try to understand the problem. If there is anything unclear, please bring up the question, and also at the same time think about some edge cases that you need to deal with especially in the next step. So let's take a look at the question. Longest palindromic subsequence. Okay. So given a string S, find the longest palindrome subsequences length in S. You may assume that the maximum length of S is 1000. So let's say the input is triple BAB. So the output is going to be 4 because one possible longest palindrome subsequence is 4 Bs. Alright, so that makes sense. Let's see some constraints. So the constraint is the length is within 1 to 1000. And S consists only lowercase English letters. So that sounds good. So at this moment I don't think we have any edge case at this moment. But if we want to, if there is something we could specially deal with, it could be like, what if the string has only one character, then we just return 1 for it. But otherwise I cannot think of any edge case at this moment. So having said that, let's do the next step. Let's think about how to find the solution. So how to solve this problem? So I think it's a pretty typical DP question. So what we could do is, so for DP we need to decompose the original problem into subproblem, and find the optimal answer for the subproblem, and then recompose the result to find the solution, the optimal solutions for the original problem. So having said that, it's mostly about finding the DP formula for it. So let's see. Suppose we want to find the dpij. So dpij means the substring from I to j, what is the longest palindrome subsequence. So how to compute this? I would say if as let's use zero-based index for the string itself. So dpij means that, so if s I is equal to sj, then it means we just need to, so it's pretty much just like dp I plus 1 j minus 1 plus 2, because so if the begin character and the end character are equal, then we could just compute dpi plus 1 j minus 1 and then plus the 2 on top of it, which is a maximal length which is the longest palindrome subsequence within I and j for the original string. Otherwise, so this is if start is equal to the start character is equal to the end character. Otherwise, if they are not equal, actually we are looking at the maximum within dpi plus 1j and dpi j minus 1. So if the starting character and the end character is not equal, then the longest palindrome subsequence is actually like, we don't care about if we just leave the starting character out. what would be the longest palindrome subsequence within substring from I plus 1 to j, or from we just leave out the ending character and we see what is the longest palindrome subsequence between I to j minus 1. So that's pretty much it about the DP formula. So having said that, the runtime is gonna be n squared, and it is the length of the string. So the next part is about doing some coding. So for coding, we care about the code correctness, the readability, and also the speed. So let's do some coding here. So first of all, we need to say, do we need to deal specially if the string is a single character? I think it should be, we should be able to cover this in our general logic. So we will say int dps equal new int the s dot length. We will say for int I is equal to 0, I is smaller than s dot length plus I. We have dpi as true. Dpi as 1, because a single character is a palindrome subsequence. And we will say if I is smaller than s dot length minus 1, then we will try to see if s dot car at I is equal to s dot car at I plus 1. So if they're the same, then we are going to set dp I plus 1 as equal to 2. So this is about initializing the DP formula. So the next step is to have dp I plus 1j. So this is about saying dp I plus 1j. So I is equal int I is equal to 0, I is smaller than what is that, s dot length, and plus I. So starting here, what is a j? So we will say int j is equal to, because essentially the result is based on I plus 1j and ij plus 1. So if it is that, so it is I plus 1j and ij minus 1. Okay, so let's see. If I compute this and I compute that, I plus 1 or I plus 1 j minus 1. Yes, so this is j is equal to, let's say, length as equal to 2, and the length is essentially smaller than s. I would say I plus length is smaller than s dot length, and plus I. So I will have j as I plus length. So if that's the thing, yeah, so this is I, so it is Okay, so let me draw something to think about the sequence. So essentially, we compute this, and the thing is based on. Okay, so it's like if it is a matrix, then we first computed all the things in the diagonal, then one layer upper, then another layer upper. So it would be something like I should start from 2 0 1 2. I should start from so I should still start from 0, but ij and I is smaller than that. Every time we just need to see one layer. Each time we just do one layer. Cool. Yeah, like each time we just do one layer. So if it's 0 plus 2 and this is plus 2, that plus 2. Okay, so I think it's okay. So I will say dp. So first of all, we need to compare the character. If s.car at I is equal to s.car at j, what we need to do is we will set dp ij as equal to dp I plus 1 and j minus 1. So yes, and then we will, otherwise it would be something like dpij is the dp is mass.max dp I plus 1, this is dpj minus 1, sorry, dpi plus 1j or dpij minus 1. So that's the formula, and finally we are going to return dp s.length minus 1, and this is another s.length minus 1. So after we are done with coding, it's time for us to do some testing. So let's try to do some tests. So first of all, let's say we have the matrix, which is something like initially or 0. Let's just use this test case. So for testing, usually we need to do some sample sanity check on top of the logic using some simple example, and at the same time you can do some sanity check about the logic and also communicate about the idea to solve this problem, explain this piece of code to the interviewer. So first of all, we will have initialize all the things on the diagonal stuff as 1. And for this, we are going to see if the neighbor 2 characters are the same. So if they're the same, then we are going, so this one is 1, this one is 1, this one is 0, this one is 0 as well. So let's do some computation. So okay, so it is so the final goal is to get so dpij, so this dpi, this is dp00, so the final goal is to have dp, this is dp00, the final goal is to compute dp0. Sorry, this should be return dp0 and the s.length -1. Okay. Yeah, so this one, so to compute this, it's mostly based on the comparison to compute between those two characters, which is the first character and the third character. And if they're the same, it's pretty much just this plus 2, which is 3. So similarly, we are going to do this and see they are so for this this is 1 and 2 3 4 1 3. You need to compare this character and this character, so they are the different, so you just need to get which one is the maximum, whether this one or this one. So this one is the maximum, we are getting it to 1. And for this part, we compare the B and the B. So they're the same, it is pretty much just this 1 plus 2, which is 3 now. And for this, we see that there are different characters definitely, so we set this as 3. And for this, we see there is same character. So they are, for this one it's 1 and the last one, so they are the same character, but so they are the same character, so we are just going to have this to be this plus 2, so this is 2. And also we compare the last thing. You see they are the same. So if they are the same, let's see what I did. I think there might be some mistake somewhere. So for this, like 2 to 4, it should be 3 here. Why it is not 3? Like for this one, it is 0 and 4. So this one, it should definitely be a okay. So this should be definitely based on this one or this one. So this should be 1 actually, and well, this one should be 3. Yes, this is better. So let's see, the first character and the last character, they are the same, so it is okay. So I think for the comparison, for the computation of this, it is the second character to the fourth character. So this one, it should be actually, it should be, so they are different. So this B is not equal to this A. So it is mostly based on this place or this place. But for this place, it should be 2 actually. Okay, so I think I did make some mistake about the simulation. So let's restart. So everything start here. We set this as 2 and this set as 2 as well. This one different character, so 0. This one different character, so it is set as, oh, so if they are not the same character, then we should set them as 1. So dp I plus 1 should be set as 1. Okay, so we should set them as 1 at this moment. To compute this, we compare first, they are the same character, so this is set as 3, this is set as so those two different are two different characters. This is set as 2, this one is set as 3. Then this layer, for this layer, we see that B is not equal to A, so this is 3, we see that this b is equal to this b, so we are going to set this as 3. And for this one, because the start b and the last b is the same, so this is set as 4. Okay, so I think yeah, I think that's mostly about it. Let's give it a run and see how it works. Alright, so it is dpi I plus 1. What's that? Array required, but int not found. Oh, okay, so yeah, so there's some typo here, definitely. So it is a 2D array, which is a matrix. So this is dpi I as true, and this is dpi I plus 1 I plus 1. Okay, okay, so I think it should be okay now. Okay, so this is getting us the wrong answer. Output is 0, but it should be 4. Why it is that? So let's see, first of all, we have the dp initialized as all 0, and so dpi I as 1. So if it is smaller than this, we see if they're the same thing, then we set this as 2, otherwise we set as okay, I and I plus 1. Okay, so this is 2 or 1. Okay, so the next part, it is mostly about I2 as the length, and this is a layer. So let me just run through it more seriously. So for the first layer, it is covered by this, but this dpi and I there, it is equal to as 1. So we set all of them on the diagonal as 1. Then we compare if the character at I is equal to the character at I plus 1, then we set dpi I plus 1 is 2, so which is like this. And for those two, we set as 1. So for the next part, we have for this layer, I is equal to 2, length as 2. Make sure that I plus the length is smaller than as the length plus it should be it should, so this is okay, so this is I equal to 0 and the length, so it should be something like so instead it should be something like this. Let's say int length as equal to 0, 2, and the length is smaller than as the length the plus length. We will have I is equal to 0, I plus the length is smaller than as the length, and then plus I. So this should be so essentially we are going to layer by layer. This is the first layer, this is the second layer, this is the last layer. So this is length as equal to 2, length is equal to 3. Okay, yeah, let's give it another shot. It's wrong answer again, so let's see why. Seems like I get stuck somewhere. So let's see, we have the 2, length as 2, and length is smaller than as the length, so it is plus the length. So I essentially start from 0. We make sure that I plus the length is smaller than the as the length plus I. So J essentially it is I plus the length. and we make sure if s dot card I is equal to the j, then for the first layer length as 2 we sure, so this one it's essentially setting as 3. Let me just output the entire array to see which one I'm doing wrong. So if I is equal to s dot length the plus plus I, yeah, so in j is equal to 0, so s dot length plus plus j. So this is as just a dp ij plus just a print, and then okay, so let's take a look what is the array. So it is okay, so it is 1 1 1 1 2 2 1 1, but for this layer I think it's doing something. Oh, okay, so it should be plus 2, which is a typo there. So after fixing that, I think we should be good. Alright, so I think this should fix the bug. Let's give it a submission. Okay, so I think we should be good about this solution. So that's it about the solution itself. Sorry about me getting stuck, but that could happen during the interview. So just maybe a showcase to let you know during interview if you get stuck how to debug. So so that's maybe a good example. So thanks for your time watching this video. If you find this video a bit helpful, please help subscribe to this channel. I'll see you next time. Thanks for watching.